Hello and welcome everyone to a new OWASP Switzerland chapter meeting. My name is Rob and I'm very pleased to welcome you once again together with my colleagues Patrick and Sven. You don't know too much about OWASP yet? No worries, you'll find the URL just right on this page is owasp.org and you'll get all the information needed. Or even scan the QR code because life is easy sometimes. You know about OWASP and you would like to give something back? How about becoming a member? And there again is a QR code, or just go to the URL owasp.org/membership and you'll figure out all the information needed. That's not really why you're here, right? You're about to go to listen to a very interesting talk, and you will have the possibility to ask questions. So, how do we do that? There are two possible ways. If you're listening and you viewing this on YouTube, just use the chat feature if you have an account here. If you don't, and this is perfectly fine, we still have you posted. Go to owasp-switzerland.ch and you will have the possibility to ask questions anonymously. How does that work? Well, first of all, there is this window where you can but don't have to enter a name. And there is the other one which you use to write down your question. Simple as that. Well, not that. There is something missing. Well, very tiny, but see that down there? This send button? Yeah, you have to click that. Otherwise, we won't see your question. But aside of that, that's already it. So, with no further ado, I hand it over to you, Irasara and Benedict.
Thanks, Rob, for the introduction here. Let me share my presentation. Hope everybody can see that. All right, perfect. All right, so yeah, welcome. Thanks for the warm welcome to our friends at OWASP. My name is Benedict, and Irasara and I are going to present to you our topic of security aboard the Niantic ship, and maybe start off with a bit of an agenda just to give you an idea of what we're going to cover. First, some kind of intro, then we're going to talk about our infrastructure, challenges and things that we did there. Next one is the software side, and then I'm going to give some kind of example with the current product that we are working on. After that, Ira is going to talk about cheat and abuse, anti-cheat measures, and our general challenges. And after all of this, we will have a little bit of time for questions, and we'll gladly answer those if possible. So jumping right in, who are we? I'm first going to introduce myself, and then I will hand over to Irasara to do the honors as well. My name is Benedict. I work at Niantic as a software security engineer, and I'm primarily focused on making sure that our build and software security is fine, and we have proper guidelines for our developers and supporting tools to make sure that our products are safe from the software security side. I also do design and code reviews, and in my free time, I like to look into crypto and do hiking, and also like to take a picture from time to time. You are?
Hello, everybody. So my name is Irasara Senarathne. I'm also a security engineer at Niantic. And my role at Niantic is basically to work on product security. I do reviews for our products, and that includes helping our teams secure their games, which I will talk about in the later part of this presentation. And in my free time, I enjoy writing and hiking, and I also take a general interest in security and privacy-related topics.
Cool. All right. So let's jump right in, right? But before we do that, unfortunately, we have to do a little bit of a disclaimer here, because we are not representing Niantic, and we're not speaking for Niantic. So we're essentially just giving our own opinion and sharing our own views and any kind of references or examples that we give about Niantic are just there to give some kind of illustration and do not necessarily reflect what is actually in place at Niantic. So to also be a little bit applicable for everybody else who's listening in. That said, though, to share who Niantic or what Niantic is, we are a AR-focused development company. We want to inspire people to explore the world together. And I think most of you, if you heard Niantic before, probably have some kind of experience with our created games, such as Ingress, most notably also Pokemon Go. And just recently, we have released Pikmin Bloom. All of those are augmented reality related games that heavily leverage location and interacting with the real world to have some kind of more active and less of a just completely detached from reality kind of gameplay experience. So what we really want to do is we want to create kind of shared experience with other people, and we want to create experiences that actually relate to the real world. That is why augmented reality is super important and super interesting for us from a development perspective. Also, security and a lot of other areas are currently hiring. So if you feel inclined, or if you find something in the slides and think like, oh, I think I could be a good fit for joining Niantic, feel free to check our careers site out. It's careers.nianticlabs.com. And we'll be happy to see your resume, and maybe you will be on board our Niantic ship soon. So yeah, go ahead and apply if you want to. With that being said, let's jump into the actual topics. First of all, I want to share our infrastructure challenges that we have. And there are several, let's say, kind of 3 things that are our biggest challenges, essentially. One of them is our services and the general scale that Niantic has. So we want to have a service infrastructure that essentially facilitates and scales to experiences that allow millions of players. And at the same time, we also want to give our developers a lot of flexibility in trying something new if they want to try it, or checking out a new feature, or maybe developing a completely new game or kind of experience or feature in one of our games. So all of this requires a lot of scale and specific, let's say, it has some specific challenges when it comes to how we create our services. So we need to have some kind of self-service model in place to ensure that the development environments can be used by the developers without a lot of hassle and interacting with other teams, maybe security and things like that. So they can instantly spin up, for example, some kind of development environment, and in the cloud, run their game, check their feature, and by that have a lot of let's say velocity when it comes to creating new features and overall the development process in terms of flexibility. So at the same time, this means we need to enable the developers, and also at the same time we have a lot of services that are common to the different applications. So not every service is shared, but some of them are. And this is kind of a challenge because we rely on several different services rely on the same kind of platform functionalities in some cases. So that kind of wraps up our, let's say, biggest challenges when it comes to services and scale. So as I said, the scalability and overall performance of our platform is very important, and the flexibility and enablement for our developers at the same time is super important as well. And one of the keys here and another challenge area here is the actual cloud platform where we're running our products on. And I'm not sure if you're aware, but most of the cloud providers that currently have some offering today are not secure by default. They're very much focused on easy access, getting things done quickly, but most of the time not really securely. And that is one of the big challenges here, because at the end of the day, if we allow our developers to run or to execute some kind of service in their environment, that also means whatever this particular project they are working on has access to in the back end or something like that could also be compromised in case the developer this kind of development environment gets compromised and is not secure. And for that, this is also one of the big reasons, or one of the big challenges that we face, that security is not baked in by default with all those cloud providers. And in general, since you can essentially create a lot of infrastructure with just a few clicks, there is a lot of ways things can go wrong and a lot of possibilities to misconfigure your cloud platform. Just think of opening a port or essentially allowing traffic from one direction to another. Those are different things, and not every developer has a full view of all the different infrastructure components and how they function in a cloud environment. So that leaves a lot of challenges and also a lot of potential for things that can go wrong in terms of security. And with essentially the next point, I kind of hinted at to this with the previous points a little bit. As mentioned, Niantic is a very, let's say, flexible and at the same time also kind of startup spirit company, where we want to enable our developers, we want to give them the tools and the actual possibility to try things out and make changes themselves and experiment a little bit. And that is kind of at least in the context of security, that can kind of be a problem, especially if you think about all the different things that I mentioned before, such as the cloud platform that can be misconfigured easily, or the general accessibility of all the different services in our backends. So culture is another kind of big pillar when it comes to all the challenges. The awareness for some of the developers is more focused on the, let's say, feature side and the implementation side, and security is sometimes just an afterthought. If you're also working in this kind of field and have, let's say, also implement or work with developers closely, I'm sure you've seen the same thing happen as well, that security is kind of an afterthought in some of the places, and not every developer has the full, let's say, awareness or the minimum understanding of all the features that they use, or in general of all the things that can go wrong, either while writing code or setting up the infrastructure. And now thinking of all the different, let's say, ways how you can approach this, just in the context of infrastructure, to give you an idea, I tried to have, let's say, 3 key elements or 3 different kinds of components, so to speak, that enable this kind of transition to a more secure infrastructure. And those are essentially education, standards, and in general, enablement to foster adoption, for example. And those 3 pillars are essentially the same kind of pillars that are important for our software and build challenges as well, which I'll be showing later on. But let's have a look at all the different education steps that we took to ensure that our developers have a better understanding of how GCP in this case works. So we had security-specific talks regarding features of GCP, areas where things can go wrong, to give the developers the tools or essentially some better understanding of things that they could potentially misconfigure, or how they can securely set up their projects. And another key component here is essentially having knowledge base articles or in general guidelines that we can point our developers to, so they can read up on certain topics that pop up regularly and that we can't properly address with, for example, standards or some kind of other technical measure. Because at the end of the day, we really rely on our developers and our teams and engineers in general to do the right choices here. So people are key when it comes to this whole adoption, and also key when it comes to securing infrastructure and also software and build. As I said, 3 pillars. Second pillar is standards. So my colleague essentially created some kind of automated tool that has all those different standards that we have built in. This is also part of the enablement. For example, there are some automated firewall changes that are implemented, permission policies that are applied. So, for example, you don't have full access right from the get-go when you're creating your project. Instead, the number of permissions are minimized to ensure that at the same time, if you're spinning something up and you don't really need any additional permissions, you can still do everything you need most of the time. And if you really, really need those extra permissions, you could grant them yourself, or you could request having additional permissions if necessary. We also implemented a lot of constant monitoring of our environment. And overall, we leveraged a lot of GCP functionality here to enforce certain functionality and certain standards and certain actions to make sure that there is, for example, no mix-up between development and prod and stuff like that, which can not only happen, for example, could not only happen at Niantic, but it could happen at any other place. And key of that is also, as mentioned, enablement. So we want to give the developers a tool that allows applying all those standards without having them to interfere, or without them having to make specific changes to their code. So they can just like create a new project with one click. And there is also a port management tool that we provide, allowing us to better monitor and at the same time enforce certain kind of, as I said, standards. And another point when it comes to this enablement is creating these baseline hardened Terraform scripts that we have, that have all those different security features baked in, and make sure, for example, that just give examples, right? So load balancers have certain configurations when it comes to HTTPS, or the subnets in our network are designed a certain way, and Kubernetes versions, configurations, and things like that are abstracted from the developers and what they have to do when they just want to focus on developing instead of fiddling around with their infrastructure. So yeah, those are the 3 pillars. Same 3 pillars, as I said, apply to software and build challenges. But before I go into all the different solutions or specific things that were applied, I also, again, want to shed some light on the challenges that we face in software and during builds that we have at Niantic, so the overall development process. Again, here, culture plays a huge role. We leverage a lot of automation during our development processes, and we have a solid CI/CD pipeline, for example, And at the same time, there is not a lot of, for example, like standards across teams, because teams have most of the time been autonomous, and there's a little bit of siloing going on, meaning the teams are mostly doing their own stuff, and if they do make some kind of improvements or changes, not all of the good things, or sometimes also if like in general, there is not a lot of synergy between the teams happening most of the time, which is enabling the teams at once to be very good at what they're doing specifically, but on the other side means that especially when you're coming from the security perspective, you want to try to harmonize certain actions that are being done, for example, like how the CI/CD pipeline works, or how certain coding strategies are applied, or some kind of checks are applied. And due to the fact that there is a lack of standards, and every team does it kind of different between the teams, even, it becomes really hard to get a good foothold into these let's say, into these development processes and make those more secure. So culture, again, plays a role in terms of how Niantic grew here, and overall adoption of those standards and things like that has been something that is less of a concern, because this, again, kind of startup spirit and people wanting to more freely express themselves, especially in terms of what they do with our platform, is something that goes against those standards, or having standards in those cases a little bit. And another important factor essentially is technology, right? So if you think about technology, you may think about the supply chain, for example, thinking of supply chain risks from a security perspective. If we're looking at how a development process works today, we see there is a lot of different technologies involved, and essentially all of them rely on some kind of again, supply chain process and development process. And there's a lot of ways where one bad apple essentially could influence everything. So it's really hard to get a full grasp and also a full coverage when it comes to security of all the different technologies that we use. So it's a really, really hard area to cover. And we have some tools in place, but again, it's not all perfect. And we also rely on our teams to make the right decisions. And what also comes into play at Niantic, at least, is and maybe in the companies that you're working for as well, is there is some kind of tech debt involved everywhere. So, for example, you might have some kind of old MS SQL server running, or some kind of very old Active Directory that hasn't been migrated and just syncs over data and things like this. And all of those old pieces of software or libraries or things like that, they can heavily influence how secure your environment is, and at the end of the day could be used by attackers for some kind of getting a foothold into your infrastructure, and therefore harming your company in terms of security. And tech debt can also be brought in by acquisitions. If we are thinking about getting another team into Niantic or into your company, once you do an acquisition, you have to align your own environment with the one that the other company built, and have to figure out which of the parts you take. And these are things that leave usually some kind of tech debt in place, at least for some time, until this whole transition has been done. And these are the challenges that we face also when we are thinking about technology. So again, here we are looking at 3 different pillars. Security is not a, let's say, enable and flip a switch kind of thing. We really have to educate our developers, make sure they know how secure coding works, how they can build secure architecture, and also give guidance in terms of reviews and consulting when they write code or when they're providing some kind of design document, and have a look at those. And here it's super important for the security team to really jump in and make sure that we're bringing ourselves out there and making ourselves known to those teams so they don't forget about us, and at the same time also support them to make the right decisions in the development process. And another, I mean, I just said that technology or flipping a switch is not the only thing, but it's at least something that we can do. So in our case, we, for example, have some static scans, security scans that are in place to, for example, check libraries for vulnerabilities or ensure that some kind of at least baseline of secure coding standards are in place, thinking about tools like SemGrep, for example, and in our case for the vulnerability and library detection, we use SNCC. And there are other secret detection and language-specific coding security tools that we use. And those have been a real helper to show the developers what is going wrong, at least when it comes to the low-hanging fruits, and then giving them the tools to remove those by just looking at the outputs of those tools and then making a certain change and getting new feedback of, oh, you fixed it. And once it's fixed, you can actually go ahead and keep building what you wanted to build. And overall, this whole approval process of new libraries, for example, thinking back of the topic of the supply chain risk, for example, while it's super great to have another library that does one specific thing, the question is always a little bit, is it worth the extra risk of a supply chain attack having this additional library in our code base? Or should we instead just looking at, for example, writing it ourselves? And those are the kinds of questions and let's say, yeah, different kinds of thoughts that we have with security when it comes to the development teams coming to us and be like, oh, we want to use this library, or we want to use this data set, and can we use that? And those are all the things where we try to help the teams make the right decisions. And last but not least, enablement is, again, key factor. If security is always just in the way, it's really hard to get buy-in and get people to actually look at all the different outputs and things like that. So in our case, we have some kind of, or want to create some kind of easy-to-use web front ends, for example, thinking back of the infrastructure topic. And we also just want to don't interrupt the build process too much and make it an actually, let's say, pleasant experience when working with the different outputs that are coming. So there's an actual like web UI with prioritization, which helps the managers to understand which of the problems to tackle first and things like that. And overall, it's really helpful. I know it's not always possible, but it's really helpful if you can piggyback on some new improvements. So for example, if you're thinking about a new test bench that is being created, you could try, as a security engineer, you could try to get your foothold in there and be like, oh, that is great. Can we also implement some kind of security checks that are being done that are a bit more active and not only working on the code itself, but actually, for example, like sending some kind of malicious inputs into the application that is being tested, and things like that really help when it comes to enable the developers and also enabling security to do their to do the right thing when it comes to making sure that all the stuff we write is actually safe. And all of this essentially comes together with this new, let's say, new frontier called Lightship, where Niantic is going towards a more B2B direction. So instead of having different, for example, games that we are publishing, we want to enable everybody that wants to be a developer with our platform to use our platform to build some kind of augmented reality based game or tool or whatever they want to build, essentially. And for doing this, we have a lot of, or from a security perspective, we have a lot of new different challenges coming here looking at this. So we can have I'm going to show a little bit of the features, for example, that are going to be implemented or that are available through Lightship to our developers and third-party developers who want to use this software development kit, and give some examples of kind of things that concern security when looking at this. So there are some features, for example, there is some feature that allows to automatically detect what is being seen in a scene. So, for example, in this case, we can see that it identified the ground as actual artificial ground, also detect water and skies and buildings and things like that. And if we're thinking of this from a security perspective, we can see that there is a camera feed and a data feed coming in here into some of our services where some kind of image processing is going on. And if an attacker were to put some kind of malicious data in there, we really need to make sure that we don't have, let's say, issues when processing this data, and make sure this data is properly validated and cannot, for example, be used to launch an attack against our backend services, because it also could impact other developers who are working with our platform. So we have to really think with a new perspective here, because with this third-party developers that are coming in, the whole trust model as well changes. And those were the challenges that we definitely faced when creating this software development kit, especially if thinking about the new network APIs that are being provided. There's a lot of new features that allow the developers to also leverage networking sessions or create networking sessions between players, so they can interact on certain kind of augmented reality elements together and things like that. So again, here comes into place this whole trust model, again, thinking of third-party usage that we didn't have before, where everything was done by Niantic or some validated third parties. And in this case, we have like actual external third-party developers using our some parts of our infrastructure, for example, that we needed to provide for this kind of thing. And yeah, so again, all of those new features tie into this new SDK, and there's a lot of new challenges and different new security problems that or new security, let's say, topics that we had to face when securing this tool compared to what is being done before. And again, this ties into this whole topic of culture change, and is making clear that we have a solid security stance there. And overall, as I can kind of say to you, if you are facing the same kind of problems as well, especially when it comes to culture change, that is something that takes time, and try to get leadership buy-in to make sure that they are aware of all the implications of security if something goes wrong, and at the same time that they, for example, reward their developers for fixing issues. So all of those issues don't just pile up until security comes in and be like, oh, can you please fix that? Security and engineering need to really go hand in hand here. And that is some of the most important things I can give to you. And also talking from my experience is also one of the core elements when it comes to making sure that the software development process is safe, secure. And yeah, with that, I'm at the end of my part of the presentation. I'm going to hand over to Ira, and she's going to talk to you about detecting cheats and abuse in games.
Thank you very much, Benedict, for that dive into infrastructure security and some extremely valuable lessons to share. I'm going to try to share my screen now. I hope everything looks good and it's visible. Cool. Great. So in the second part of this presentation, we will focus on a completely different aspect of security at Niantic, and that is the security of our games, particularly in the context of detecting cheat and abuse of our gaming software. So in this talk, I would like to highlight 3 focus areas. I will talk about 3 different sides of cheat and abuse detection. Basically, I would like to go into what cheating means in the context of games and our experiences at Niantic in this regard. And then secondly, try to focus a little bit on the role of an anti-cheat team or having an anti-cheat team in a games company. And finally, we will dive into some explanations on what game hacking looks like and how you can detect that if you yourself are a games developer, what you can do to kind of curb that threat and counter it. Starting with cheating and abuse, what does this exactly mean in the context of a gaming client, a gaming software? So any kind of violation of your terms of service of the software or the game rules, in this case, that you set out for your end users, your players, or any kind of violation of the integrity of the software that you distribute to your end users can be considered an act of cheating or abuse of the platform. So typically, users would do this to bypass security and, of course, other game controls in place. People who try to abuse the software to gain an unfair advantage, sometimes interfere with the actions of other players and even threaten the safety of other players. Any class of these actions can be considered cheating and abuse of the software and the platform. So to understand how you can curb this threat, it's important to understand the motivation and the incentive behind cheating in games. So talking from some experience here at Niantic, if we look at why players tend to cheat, you can see that there are some obvious trends. For example, in our case, we have some very popular games out there, namely Ingress and Pokemon Go, which might sound familiar to some of you. And the sheer number of users on its own can attract cheaters. One other thing that could incentivize someone to cheat and abuse your platform is the act of being able to disturb the game board for other players. So if you have something like a shared world, a shared game board, as we do in our games, any action that you take can affect the game board for other players, and that, of course, can invite people to act maliciously or incentivize them. Other reasons are things like rare items that could be collectibles and have some trade value. Things like simply bragging rights in being able to skip the intended gameplay and being able to customize features, for example, that the developers don't provide. These are all good reasons that incentivize cheaters, and these are generally trends we see on what causes people to kind of abuse our platforms, bypass security, and try to cheat inside our games. And if you're familiar with our games, again, these pictures might, you might have come across some of these articles or these pictures before. So some instances where a player would use a third party to gain a certain advantage or gain the upper hand in the game, in our games, for our things like having rare collectibles, getting access to rare collectibles like shinies in Pokemon Go, that obviously has some trade value. Other things like claiming gyms, claiming rival gyms in Pokemon Go is another example where you see a lot of people kind of cheat in the game. There is a certain reward associated here, so that can also be the incentive or the motivation. And of course, when players have the incentive to cheat and they have the incentive to use these third-party tools for that purpose, it doesn't just lead to the problem of cheating inside the game and defeating the intended gameplay. It can also lead to more serious consequences and more serious offenses. And particularly in our case, because we have location-based games, things like threatening other players' safety based on their location information is one of the biggest challenges or security risks we have. And this is quite obvious, like, why is this bad for us as a company? Cheating, of course, causes a lot of grief for everyone involved, for both the players, that is our end users, as well as the developers, that would be us, the company. So cheating can obviously be very costly for a company. So think, for example, of a scenario where you have a lot of botting, for instance, that cause a lot of load on your servers, bots that kind of just scrape your servers, can become very costly with time. And also, cheating greatly affects player sentiment. So obviously, if your actions are affected, as a genuine user, if your actions are affected by someone acting maliciously who is able to progress faster, maybe gain better and more rewards in the game, that affects your engagement with the platform, and that can lead to players sometimes wanting to disengage with your platform entirely. So it's very important to address this issue in order to make sure that player sentiment is protected. That's not all. Our IP is also put at risk, our intellectual property. If you have people who want to act maliciously in the game, that means there are people actively looking at our source code, looking for exploits, and that obviously puts all of our code at risk and our intellectual property that's bundled to there, enabling the gameplay and enabling various parts of the software. All of this can be put at risk when people reverse engineer and target or attack our gaming clients. Other effects of this is of course the fact that we unintentionally foster a cheat economy that we don't want to be a part of. Things like rare collectibles or collectibles of any sort in the game can be traded. You can buy and sell them in a marketplace, and that's not something that we want to foster. And finally, very importantly, it also puts players at risk and their data at risk when they turn to third-party tools to gain an advantage in our games. So that's something I will elaborate in a bit more detail in a moment. However, it's important to understand when people try to abuse the software and use third-party tools, there is always the risk that these tools themselves may be packaged with malware and act maliciously and wouldn't necessarily guarantee any kind of protection of your data of any sort. And of course, all of these reasons collectively mean that it is very important to have a presence of anti-cheat if you are a games developer. So here at Niantic, using Niantic as an example, the role of anti-cheat here, I would say, is twofold. We have, firstly, a more of a community-centric role where we try to ensure the player safety and ensure fair play for our users. So what does that mean exactly? We ensure that we can enforce the terms of service that our users agree to, which we make sure that there is a certain reporting platform for players to report any kinds of cheating or abuse they see among the community, and have a system in place to be able to investigate these reports and take action. When I say take action, another very important note, when you have in place the role of anti-cheat and you try to differentiate between who is a cheater and who is a genuine player, and take action against the malicious actors, it's very important to make sure that only the malicious actors are punished, and that you avoid misfiring, because that can also affect player sentiment and affect the gaming community. So that's the first part of our role, which is more of a social role, community-centric, making sure that our players are in a safe space and that we have and we respect their trust and privacy. The second role is more on the side of systems integrity. And what that really means is that we also have a role in protecting the software that is used for the gameplay. So that means anything from the gaming client that users engage with on the front end to the back-end servers that our gaming clients talk to, our intellectual property, and all of that. Basically, all of the infrastructure and architecture. And primarily because we have a mobile gaming client, in our case, that really means we protect against any kind of attack on our software, any kind of reverse engineering and hacking attempts, and try to ensure that we have in place security that can ensure the integrity of the systems on which our games run. That being said, maybe at this point, I'd like to ask you, the members of the audience, to maybe take a minute to reflect on what you would think are some of our biggest challenges in enabling this role at Niantic. So if you're familiar with our games, or if you are users yourselves, players, you could probably guess that one of the biggest attack vectors we have actually come from the threat of location spoofing. So because we develop games that basically rely on the location information of our users to use our games and engage with our platforms, the threat of faking that location and spoofing can affect our game board very much. So the threat model here is also very different. If you, for example, can compare this with the other mobile clients in the industry, let's say outside of the gaming world, if you compare with the typical or common use case, common example of, let's say, a banking application, the threat model is different because the threat is no longer about an attack on the user or user data per se, but an attack on a shared game board, an attack on a shared world that's then going to affect all the users. And the difference here also lies in the fact that we're no longer protecting a potential victim from, let's say, downloading a malicious client or falling victim to a socially engineered scam. But we're really protecting against the threat of someone having physical access to the device where they can actively then attack our software and target the game board. That's one side of the threat model of what we protect against, but of course there are many other challenges that we face. So when players cheat, this is obviously bad for us because it opens many other attack vectors as well. It is not just about disturbing the game board, but like I mentioned earlier, it also puts our intellectual property at risk because players essentially have a client in their hands that they can now analyze to try to glean useful information. Other than that, at Niantic, another very unique challenge for us is that we have set out this incredible goal to create a planet-scale AR map. And with this particular mission, we rely on our users to upload scans of certain points of interest at their specific geolocation. So we rely on crowdsourcing for this data to build out this map. And you can imagine if users start to fake their location information and start to cheat and abuse our software, this crowdsourced data obviously becomes affected. And that is also a very big challenge for us. And that's also a huge reason why we need to ensure that location spoofing and other kinds of abuse of our software is really not possible, and we take extra security measures to make sure that we mitigate that risk and curb it to prevent such misuse. Other than that, we have problems that are probably shared by other companies, things like maps and IP scraping. Actually, server-side scraping puts a huge load on our servers, and that can be costly. Again, the cheat economy, a marketplace we don't want to necessarily foster. And finally, very important, when our users abuse the platform to gain an unfair advantage and to engage with our games unfairly, it kind of defeats our mission, the mission that we set out to achieve. So at Niantic, we build games to allow users to explore the world around them, to exercise, and also socially engage with other players. So if you have people who use third-party tools and cheating software to kind of, instead of going out and actively engaging with the game and the world around them, to kind of spoof their locations and play the game in that manner, that kind of defeats the purpose of the games, and it defeats the core values that we set out for our products. So that being said, let's take a look at what game hacking actually looks like, and let's take a brief look at what it means to detect and counter these threats in a gaming world. So when you think of someone who targets your software, and in this case, our games, we have two kinds of offenders in mind. So we have the kind of offenders that actively reverse engineer our software and exploit our games to their benefit. It may be for various reasons. It's often profit-driven, or it is driven by a community need for hacks and various customizations of the game. And then you have a second group of offenders who are the people who buy these third-party tools to engage in a malicious manner. The ultimate result, however, whichever offender you have, you end up destroying the game experience for legitimate, genuine users who may then be tempted to disengage with the platform, which is obviously what we want to avoid and protect against. So how do people generally exploit the software or try to gain an advantage? This is achieved by a few common attack vectors. So if you are familiar with the landscape of mobile threats, these terms might be familiar to you. Often users would install something we call a plug-and-play software, where they simply download another application from a third-party site, so something that is not officially hosted by us on the Google Play Store or Apple's App Store, and simply install that to interact with the game and act maliciously. You can also go a step further and do things like compromise your device, compromise the firmware or the operating system to actively debug and hook the game code. So again, if you're familiar with the landscape of mobile threats, these terms might be very familiar to you. Often hackers distribute gaming mods or modified gaming clients by repackaging the original software that we distribute. And you can simply, as a cheater, you can either install this to cheat in the game, or you have to compromise your own device by rooting or jailbreaking your device, patching your ROM, or you can also just be one of those users who actively attack the software. And in that case, someone would try to debug the code or emulate our software to look into specific parts of our software, try to analyze how it runs, and actively attack it to gain an advantage. So this kind of use of third-party software is not without its risks. I want to highlight here an incident from Snapchat a couple of years ago, where users' private data, very private data, was compromised because they were using a third-party software to engage with the Snapchat platform. And in this case, the hackers were not necessarily acting maliciously, but the third-party tool itself got hacked, which obviously led to a huge data leak. So you have to always be careful when you engage with these hacks or cheats or game mods that are out there, because you might be risking your personal data to do something malicious, and there is no guarantee that the people behind those tools, the people who created these modified clients, may not be harvesting your credentials or other private data. It may not always be the case, as we see with this particular incident, but they're probably much less likely to invest in the security and privacy of your data than, let's say, the original developers or the company responsible for the product, and in our case, the game. So detecting these kinds of modifications, typically there are a number of ways that you can use to detect them. Again, if you're familiar with what reverse engineering on a mobile client looks like, you're probably familiar with how that goes, how you would harden the client side using things like certain detections that you embed in your client, which basically rely on things like device or software heuristics that could indicate that this device that the software runs on is compromised. That alone is not sufficient. You would also want to harden any kind of any other sensitive pieces. So it's not just about the detection, but it's also about making it difficult for someone to attack your code, reverse engineer it, and make any meaningful sense out of it. So these kinds of attacks can be mitigated or can be protected against by doing things like those integrity checks. At this point, I want to highlight the OWASP Mobile Security Testing Guide, which is an excellent checklist you can actually check out, which talks about building resilience in a mobile application. And it's a very useful and very fundamental step you can take to protect your systems. And whether you're a game or any other kind of product, if you have a mobile application out there, this checklist and guide, in fact, provide a very useful starting guide to allow you to determine what's useful when you pen test your application, what kind of things should you look out for and should you protect against, etc. So like I said, this is an extremely important step, and this is actually a very fundamental step in protecting and hardening a software client. However, it is not without its limitations. So to demonstrate this case, let's look at a famous example. So let's say you have among your end users a group of users who do use a customized ROM or a rooted user. What would your approach be to this group of users? Are you going to, simply because they use rooted or jailbroken devices, essentially which gives them total control of the device, are you going to automatically categorize them as bad actors? Do you see any kind of problem there? So is rooting a device even an offense? Wouldn't someone root their device just to be able to customize certain things and not necessarily attack your software or attack or be acting maliciously in your game or on your platform? So you can see that this kind of approach is or can be problematic. It obviously depends on your use case and what you're protecting against. But generally in a gaming world, it's especially important to think about the punishment you hand out to an offender versus the offense. So you really have to ask yourself the question, when you take action against a malicious user, are you going to weigh in the offense they've committed? So in this case, if you have a rooted user, are you going to consider them as offensive as maybe a much more serious offender who has done something much worse, who has not simply rooted their phone, but also actively targeted or actively engaged with the platform in a malicious way and affected other users. So talking about this is important because it brings us to the next part of hardening a clients and detecting modifications of your gaming clients. It's not because you want to take into account these other kinds of offenses or the level of offenses someone commits. It's important to complement any kind of client-side security with something additional. And in this case, I will look at machine learning as an example, because that's a great example for games. So looking at behavioral heuristics, how people engage with the platform, what their game actions look like, is a huge complement to the client side of things, to the detection side of things. It allows you a more fine-grained approach. So relating to the case we looked at earlier, if you have rooted users, for example, you can use machine learning to do further detection to see, are these users actually acting maliciously on our platform? And that can be, that incredibly complements any other detections you have in place. And it's not just that. Things like OS provided controls. So we know on the mobile platform, quite famously, we have safety net on the side of Google, Android, and on the side of Apple's iOS platform, we have Apptest. Using things like these OS provided controls is also a huge step in protecting your games and protecting your mobile clients. So with all this in place, I have to mention this kind of circles back to what my colleague Benedict was talking about earlier. You can have all of this in place, but security is not something that should be just left to the end of your development process, and certainly not as a thought of something as an afterthought where you first develop your game or your product and then you think of, hey, how can I secure this? Security should be something that should be thought of every step of the way. So a secure design is extremely important when you design your game And when you design your product, you have to think of all the possible ways this can be abused. And that's something that should come from the very first step, that is the design. You also have to follow the best practices, fundamental things like do symbol stripping in your builds for your release builds, remove your logs and test code, and of course, pen test your builds and review these builds to make sure you know what you are shipping out to your clients and what you're uploading on a public platform like a Play Store or the App Store. In the context of games, game design is just as important as all of those other things I talked about. So whenever you introduce a new feature, it's really important to map out the use and abuse cases and always ask yourself, so can this feature put our players at any kind of risk? Does this feature offend other users? And also very important, when you introduce some kind of game action, maybe think a little bit about the incentive for a malicious user to abuse that. For example, is this game action, what is the reward involved here? Is the reward so great that people would be more likely to cheat than follow the actual intended gameplay? So these are very important questions to ask. So it's not just about hardening a client and having detections in place, but the basics of security are very important. Doing things like secure design, secure from the very first step, things like penetration testing and reviewing your builds are equally and extremely important. And with that, I come to an end of this presentation. So thank you all for joining. And a big thank you also to our teams and the OWASP organizers for providing us the opportunity to talk about our work at Niantic. And thank you very much for the audience.
Well, thank you very much, Irasara and Benedict. It was great listening to you. And we already have a number of questions that arrived on our side. I guess I will start with first some questions in the infrastructure area, and then go over to the second part of the talk and with questions on that part. For everybody out there, feel free to just continue posting your questions. We'll try to address them as they come in. But now let's get started with the first questions. I have one question here from Anonymous, who is you mentioned that you use GCP for as your cloud platform, and given from a security perspective, what would you say does Google better than Amazon or Microsoft, or do you have an idea of why you've chosen GCP instead of the other platforms when it comes to security?
All right. So first of all, thanks for the question. I'm the software security guy, so I hope my colleague will forgive me if I'm answering this. But yeah, the thing is you can definitely tell looking at GCP that it came after AWS when it comes to features and also some of the functionality and also some of the security stuff. So to some extent, it's a much more thought out and well-rounded and integrated with security platform than AWS. And it does some of the defaults better than AWS. But again, it suffers at the end of the day from the same kind of, in the base configuration, from the same kind of issues like AWS does as well. It's also very much focused on getting your infrastructure up as easy and convenient as possible. So just thinking about when you create a new project, you're instantly granted project owner permissions, which is a huge over-permissioning when it comes to the kind of capabilities that you have with this kind of role, to give an example. Because most of the work and most of the services that need to be run don't require such level of permissions in terms of configurations that you need to change, or on the service level itself. And the other part of the question, why we chose GCP, I think this is kind of this is really just guessing, but I'm pretty sure this is kind of related to where Niantic is coming from, as being part of Google and a dedicated entity from its own at some point. So there is a lot of synergy between Google and Niantic when it comes to the technologies. So that is just my guess why this is the case. And overall, as I said, GCP is a bit more, when looking at all the features that you need on a day-to-day basis, a more well-rounded kind of a platform. But this is really just a tendency, not really a general endorsement or whatever.
Great, thanks a lot. So let's stay for now in the GCP area. You also mentioned during your talk that you're monitoring the environment. Do you also apply some security monitoring? And if you do so, is it done for each product game individually or for all games together on a company level? And based on what GCP services and your experiences with that?
So we apply several kinds of, let's say, auditing mechanisms and monitoring mechanisms. All of them are most of the time apply to the whole organization, but that also means they apply to the individual projects within this organization. That we have different kinds of, for example, development environments and production environments and testing environments and things like that. And in all those different places, we have different kinds of controls in place and different kinds of monitoring in place. And we employ mechanisms such as actively looking into the GCP configuration itself, because as a cloud platform, it is relatively transparent to all the configurations. You can get information just from API endpoints and look at all the outputs and receive some information from there with regards to what kind of services are running and things like that, just to give an example. And that is something that is in place. And when it comes to what we are exposing, we are looking into several different things. And generally, what I can say is that, to give an example, the kind of way how, for example, Showdown works and generally scans like Nmap and things like this, those are very similar to what we do. We do a lot of, let's say, custom things as well that are very focused on our own infrastructure. But in general, we are trying to also have an outsider perspective and really actively looking at what are we exposing to our world, to the world, and in what way. And for that, we have also like continuous scanning in place with different kinds of methods. But as I said, just to give an example, like for example, like Nmap scanning or Showdown are things that are very comparable to what we do.
Okay, thanks a lot. And for the next few questions, we're going into the domain of DevSecOps, I guess. So Dorota asks how you mentioned that you use a lot of automation in your delivery processes. Do you also have some DevSecOps pipelines or processes in place? And do you also have automated pen testing in that process, or do you do that manually?
Okay, so we have automation that's into the completely in place when it comes to the build process, and as mentioned on the in the slides, there are static tests in place, for example, to ensure that the libraries that we use are monitored for vulnerabilities, and we also have a clear understanding of what kind of dependencies we have in the form of libraries, and also transient libraries, for example. And we also employ some static code analysis to ensure common issues are captured. This is not a real example, but if you think about it, just to paint a picture, like string concatenation in the context of an SQL query, for example, would be something that is picked up by some of those tools. And these findings are then returned back to the developers, and they can react to those, fix those, and based on that, we ensure some kind of baseline what is coming out of the pipeline in this context of DevSecOps, essentially. And when it comes to the specific technologies, so code scanning, we're employing semgrep with a lot of different rules, public ones, but also ones that we created ourselves. And for the library scanning, we use SNCC, which has been quite helpful. They also have a code offering, for example, that supports automatic detection of issues. So there's some kind of overlap in features, and in general, those are the kind of tools that we use there.
Did I get it right? So basically, when you have a finding, it's kind of analyzed by the security engineers and then passed on to the developers to fix.
Usually, the developers themselves look at those first, and they are more than like they're usually fixing those issues themselves. But sometimes there may be more than one issue coming up, and then a bit more prioritization from the security team is necessary to ensure that we're tackling the ones that have the highest impact and the highest, let's say, time spent versus profit attached to them. Profit in terms of we can gain a lot of security improvements from fixing this. And I also wanted to add, like, there's also some active scanning in place, as mentioned, penetration testing. We also not only do this kind of auditing of code, of course, but also look at what we are shipping in terms of the clients, in terms of the servers, and reviewing those not only on the code level, but also from an outsider perspective, kind of as a active and red team approach, looking at that.
What I think would match quite nicely in right now as the next question is, if you have actually some false positives, who does them mark them, accepts them, and how is this handled in your case, where you have the security engineers and the developers involved?
So again, most of the time, the developers themselves are enabled to fix those. All of those tools have features to ignore certain findings, for example, for just a little bit of time. And most importantly, all of those exceptions have some kind of reason attached to them. And that is one way developers are able to turn off false positives, for example, or situations where a library is being detected as an issue, but we are actually not using it in the way where it's vulnerable. So we are kind of putting it back in the priority list and focusing on other issues first. And the developers know best when it comes to what kind of dependencies we have and how we use them. So they have not only the tools to let's say disable certain findings, but also give reasons why. And if they are unsure, they come back to us and request additional prioritization, for example.
Thanks. And I guess this already answers the first part of Parami's question, how much emphasis is placed on DevSecOps at Niantic, as a first part of the question. And well, do you have some GitOps also in the picture, and how does this help to improve security in the CI/CD pipeline in your case?
So DevSecOps is a super important part as part of, first of all, the standardization piece that I mentioned, trying to have a consistent approach in terms of how we're building, how we're deploying into certain infrastructure, and how we're testing in between, be it security testing or application testing in general. And so that is the most important step, essentially, when it comes to this whole pipeline. So the sec in DevSecOps really plays an important role there. And when it comes to the GitOps and other ways how we interact with that, so we have some kind of hooks that help us figure out what's going on and report some information back. We don't really use a lot of, we try to minimize what is accessing our code repository, because it's a very important and very, let's say, critical piece of technology. So we try to minimize the different ways how developers can interact with this. And so we don't really employ things like that somebody might think of as like using some kind of Slack command or something like that to interact with a certain endpoint in GitLab, or start some kind of build process via Slack or things like that. Just to give an example, right? Because some teams actually do this, but we really want to refrain from that, because GitLab is such an important piece and want to keep it clean and without any kind of external access as much as possible.
Thanks a lot. So I think we're through with the infrastructure part for now. So let's jump over to some questions relating abuse, cheat detection, and so on. First one is, well, obviously they mentioned that, well, wouldn't it be an option to, well, reduce affordances to cheat, so to make cheating less attractive, for example, for region locked Pokemons or something like that? Is this something you actually include in your thoughts, or how does this work?
I think with any kind of feature, we always think about the reward versus the effort. And yes, it makes sense to reduce any kind of incentive for someone to cheat. But at the same time, you also have to balance that with keeping active players engaged with the platform, making sure that they continue their gameplay. And of course, that there is an incentive for legitimate players also to continue to be engaged with our platform. So yes, we always do this kind of balance to try to figure out, okay, if you introduce a particular new feature or new collectible, what is the effort here in terms of game progression, game actions involved, and is this going to kind of attract the negative, too much negativity in terms of too many cheaters attacking our game?
Thanks. When it comes to cheat detection, you mentioned that on one side you have the client side controls, and as a server side controls, you mentioned AI. Are there also kind of traditional algorithms that you apply on the server side? And if so, can you kind of say in what areas or what domains, what parts of the game or the system does what approach work best?
So as for traditional approaches in terms of machine learning, I mean, it really depends on your particular use case. So I'm not sure what that means in the context of our games here. But any kind of behavioral heuristics that you can gather, and then from that to determine, okay, this game action, for instance, it doesn't fit the norm of what a legitimate observed or controlled player we have, or controlled user that we know of had in place. So any kind of things that deviate from that kind of a norm is a trigger. And those are the sort of detections that you would want to have in place. But any elaboration on what you mean by traditional, and I could probably answer in a bit more detail.
I believe that a traditional algorithm would be something that doesn't involve any AI at all, so no artificial intelligence at all. Traditional thing you code down, like if thing A happens, then maybe chances for a cheat are 5% or something like that.
I would say this is more about looking at game actions and actual behavior of a user, and then comparing that with a known or a known cohort or a controlled group.
So basically, you say it's more like the overall it's the domain of AI. You basically do not really apply traditional code on that area. Or
it's
not,
more
to much
about
extent.
developing a model that can kind of learn from what we know as is a known good cohort, and then using that to, of course, you have to train that, and not just use a control set that we would use to develop the algorithm, but you train that, and that's the application of machine learning to kind of develop that into a more robust system. And the thing is that this is something you would use in conjunction, or you complement that with other detections, and it's not something to be relied on solely. So like I said, it's something you would probably want to do when you want to do things like more fine-grained detections. So for example, you have other security measures in place, like client-side detections. Let's say someone trips any of those detections, and then you want to kind of do a more fine-grained analysis. This might be because you want to, like I said, balance out the punishment you hand out to someone with the offense they committed, or you're simply interested, more interested in what this game action meant. What was this user trying to achieve when they tripped this particular signal? So it's something to be used in conjunction, and do that kind of fine-grained analysis, and I would say not entirely rely upon that. It's a few different pieces coming together in terms of using it to identify who really is a bad actor and then take action against that person.
Right. I think that already answers an anonymous question that was like that. When, as you rely on machine learning, well, how do you ensure to avoid punishing users based on a bias? For example, they are often taking intercontinental flights and have extremely different locations on their devices. So that's completely different than most of the other users, obviously. But you already kind of made that statement that you have additional controls. So you would be able to also identify this and prevent false positive in this case, I guess.
Yeah, indeed. And that's a very good example to discuss, because it's not just also about the detections, but with this kind of an approach, it's also about testing very thoroughly before you hand out punishments or disengage users from your platform. It's extremely important to do a sufficient amount of testing and quality assurance on this kind of a detection, and complement it with other signals, as you said.
Cool, thanks a lot. Then I'll have a final question. Maybe that's all a philosophical one. So it looks like there are lots of cheaters out there, and there are many spoofer apps, and that's real business actually. So do you actually think at the end of the day you're successful in your work, or is this a never-ending cat and mouse game?
I think security in any domain, it's an arms race. That's the most commonly used word to describe it. It's always a game of cat and mouse. And of course, we are successful. If you've looked at the history, I believe there's been a lot of improvements we've made. But of course, that doesn't mean that the development ends there. There's a lot more we can do in terms of ensuring fair gameplay for our users, and that's something that's continuously being worked on and being developed. As with any other domain, it is a constant arms race. Yes, offender versus defender.
I think that's a very good closing word, actually, that, as you said, it holds true for most of us working in this business, I guess. We're still always on a run and try to make more progress than the other side.
Yes, exactly.
Thanks. So from my side, I thank you very much, Ira and Benedict, for being here and being the speakers. I'll now hand, as we have no more questions in our pipeline, I'll hand over back to Rob for final words or his own questions.
Thank you very much, Paddy. I think I don't want to bother you with too many more questions, but I would have one note. Firstly, you mentioned SamGrep, and funny fact or fun fact, like exactly 1 year ago, we had Clara talking about SamGrep. So if you, the two of you, or someone of the audience want to have a look at what we did there, the slides are still on our chapter page. And then from my side, I would have more questions, but your time is valuable. And so I reduce it to one, put these all aside. You mentioned you're hiring, right, in the area of security. So you also talked about cheating, hacking. Are you specifically looking for former or still active abusers of your games that could work for you, like they do for agencies with hackers? Or isn't that too relevant to you? So to people with knowing how to abuse your products.
I think that kind of experience in itself, we're not actively searching for that. What we're looking for are people who are familiar with these concepts and have an interest and motivation to work on these topics.
Okay, perfect. Thank you. In that regard, thanks very much for your time. And to the audience, if you want to rewatch it, it stays on YouTube for now. If you want to see the slides, please wait a little longer. All the information around OWASP and OWASP Switzerland in general, you'll find via the URL shown or via the QR code. Thanks everyone and have a good one. And we are